Today we will discuss about the stability of butene, isomers of C4H10. Okay, C4H10 isomers. We have to compare the stability of butene. So there are three types of butene over here: isobutene, trans-2-butene, and cis-2-butene, and 1-butene. Okay. So there are four isomers of butene C4H8. I have to write down here. Okay. So relative stability of butene will find out. So question is, which alkene is more stable? Correct order of stability of all these four isomers of alkene, that is butene. Which alkene has also zero dipole moment and is more stable than cis form? So say now I'll do that. Okay, now see, this isobutene is gem disubstituted, this is gem disubstituted, this is this is disubstituted, this is disubstituted, and this is not substituted. This is normal alkene. Okay, monosubstituted you can say. Now which alkene has also zero dipole moment and is more stable than cis form? So first we write down isobutylene, CH3, CC. H3 double bond CH2, that is isobutylene. This is the most stable alkene butene isomer. This is gem disubstituted isobutene. Why it is so? Because it is having 6 alpha H, 3 alpha H here, 3 alpha H here. So 6 alpha hydrogen is there. So it will give you it is stability because of the hyperconjugation. 6 hyperconjugating structures will get. Okay, so because of this hyperconjugating structure, more will be the hyperconjugation structure, more will be the stability. So this is disubstituted as well as hyperconjugation work on it. That is why isobutylene is the most stable butene, followed by trans-2-butene. Means most stable is isobutene, then trans-2-butene, then cis-2-butene, and then 1-butene. Okay, got the idea? Here you will get all the answer. And now when there is question which is having zero, almost zero dipole moment. So trans-2-butene is having almost zero dipole moment. Okay. Here I have written trans-2-butene is having almost zero dipole moment. Why it is so? Because there will the alkyl groups are just opposite to each other. Okay, so they are having better symmetry. So now trans-2-butene, same groups are on opposite sides, so less hindrance, and so it is more stable as compared to cis, but less stable as compared to isobutene. Okay, here I told you why trans-2-butene is more stable than cis-butene. Okay, so you got the idea? Means isobutene is more stable than trans-2-butene, trans-butene is more stable than cis-2-butene, cis-2-butene is more stable than 1-butene. So this and this, and this, all these three are disubstituted, this is monosubstituted. Clear to you? So according to Sedgwick rule, highly substituted alkenes are more stable. Write down all the points which I have written. Trans-2-butene, same two group. Now trans-2-butene is more stable than cis-2-butene and having zero dipole moment also. This isobutylene is not having zero dipole moment, but trans-2-butene is having zero dipole moment. So that is why I will say that it is tricky question, that although it is less stable as compared to isobutene, but it is more stable than cis-2-butene, and as well as trans-2-butene are having two same groups on opposite direction, so almost zero dipole moment because of the symmetry. Okay, better symmetry. So less steric hindrance will be there, and it will become more stable. Okay, and more stable as compared to cis, more stable as compared to cis. Now we'll discuss the second one. See here, this, write on the structure. Isobutylene I have made here 3 alpha H here, 3 alpha H here, total 6 alpha H, so 6 hyperconjugating structure. Now trans-2-butene I have made, the two groups are opposite side to each other, that, and so it is having zero dipole moment, it is having better symmetry, so it is having high melting point but low boiling point. Just reverse to this, and see here cis-2-butene, Okay, now cis to butene, then say alkyl groups are on the same side, so there is steric hindrance. That is why it is less stable as compared to trans to butene, but still it is more stable than 1-butene, because according to Sedgwick rule, Jetsev rule, somebody are saying, some in some schools they are saying Sedgwick rule, whatever. In your school, in board, it will be Jetsev rule. Okay, sometimes this is also written, so no need to worry. You find out that almost they are both in the, both of them are same, and highly substituted alkenes are more stable alkene, and that is preferred. So here CH3 CH double bond CH2 means this is 1-butene, monosubstituted butene, less stable है according to Sedgwick rule. So highly substituted alkene is more stable than the less substituted alkene, that is the Sedgwick rule. So you got this idea. This is very important and tricky question, but very easy to do. God bless you. All the best.